So let's get started. I'm actually going to put a table on here that has some important information on it. Okay, so let me set up this table and I'll talk you through it too, because I know some of you really like to have it looking perfect. This table is going to be 9 spaces tall. I like tables. They make everything so organized and easy to understand. Okay. Then we're going to be putting our symbols in here, and then we're going to be talking about what they mean, some phrases that we use, that we can use to identify the symbol, and then we'll talk about whether or not the circle on your graph will be open or closed. I'm going to put the circle information in this table, but we won't actually look at graphing immediately. You're good, Terrence. Okay, so let's talk about the meaning of these symbols. When we read this symbol here, we call it less than. Now, some word phrases that you might see used when we're talking about less than symbols. In a word problem, you might see the phrase fewer than or below. And when you graph an inequality that has a symbol like this, we use what's called an open circle. We use an open circle because we're trying to show that that actual number is not a solution. It's everything less than it that's a solution. Okay. The next symbol is greater than. Some phrases you might see associated with this are more than, there are more than 20 students in this classroom. Or above, the temperature is above 50 degrees today.
Only?
Huh?
Only?
I know. And when we graph this, we would use an open circle as well, because we're saying everything greater and not equal to here. Now this next symbol is less than or equal to. And some word phrases that you might see for this are at most, or no more than. And in this case, we use a closed circle because the number can also be a solution, which I'll show you in just a minute. And this symbol right here is greater than. Or equal to. Some word phrases you might see for this one are at least or no less than. I need at least $100 to go on the trip that I'm going on. Or I need no less than 25 students to be here to teach the lesson. So you could have 25, you could have more than 25. And again, this one is a closed circle. And I'll explain that a little bit more when we do our graphing. Now, I know you've been exposed to inequalities before, but we're taking it to the next level. Okay, so you guys already understand what inequalities are, but we're going to be doing algebraic inequalities. Anytime you see algebra or algebraic, just remember that there's variables involved, okay? So algebraic inequalities are inequalities that contain variables. And I'm going to put the S in parentheses. Usually it's just one, but sometimes you'll have more than one variable. But for our sake in this class, we will only be doing inequalities that contain one variable. Oh, Mr. Kelly. He is so loud. He just keeps going. What is he saying?
She's singing a song.
Oh.
He's singing,
It sounds like he's yodeling.
what's that? When you sing that, you're screaming. I know the song, but I don't know the name.
Like, what's the song?
All right, let's go ahead and graph a few inequalities, and then we'll move on to just solving the one-step inequalities. Okay, x is greater than -4. Now when we graph this, It does not need to be a super spectacular number line. I usually just put the number in the middle and put a couple of numbers on either side and call it good, okay? Now, in this case, we're saying that x has to be greater than -4. It can't actually be -4, which is why when we have this symbol, we use an open circle. The open circle shows us that -4 is not shaded in. It has to be everything that is greater than -4. So that's the purpose behind the open circle, is just to show that it cannot be a solution. So when you're looking at this, the graph really just shows you what all the solutions are. And we just assume that arrow means it goes on forever, infinite. Okay, there's an infinite number of solutions to that inequality. So -3, for instance, is a solution, -2, -1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and all the numbers in between them. So even -3.99999, it is greater than -4 and is a solution, okay? So like I said, infinite solutions. So let's take a look at another example. Let's say that 1/2 is greater than or equal to m. Okay. Well, in this case, 1.5 can be a solution, because it's greater than or equal to 1/2 here, 1.5. So I'm going to use a closed circle, and a closed circle shades in 1.5 to say, yeah, that's a solution. And in this case, 1.5 is greater than or equal to m. So that means that m is actually less than 1.5. So I'm going to shade this side right here. And I highly recommend just mentally checking your answer too and saying, okay, well, I just shaded this side here and 0's on that side. So is 1.5 greater than or equal to 0? Yeah, so you know you're good. If I had put 3 in, if I had shaded the wrong side, if I had shaded this side, and then I chose 3 to test out, I would say 1.5 is greater than or equal to 3, and that's not true. So that's how you can kind of help make sure you've shaded the correct side. All right. Real quick, I just want to write the definition for a solution set. So a solution set is all of the solutions of an inequality. Okay. So, and that's what we're really showing on the graph too. We're showing every single solution. We call that a solution set. A solution set is all the answers to an inequality problem, which we can't write all the answers down. Like I said, there's an infinite number. So that's why we use inequality symbols and we use the number line to show all the solutions, okay? So when I talk about the solution set, I'm talking about all of the answers to an inequality, and it's an infinite number. Okay, last year in 6th grade, did you guys solve one-step inequalities? Yeah? I hope so. Well, I'm going to do a quick review of it, just 2 quick examples, and then I'll let you guys get your homework done and you do not need to do your homework on paper tonight.
Oh my God, let's go.
I know. Okay, so let's do 2 examples to make sure you're good.
I already did my homework.
Okay, so let's do like 2 quick examples here to make sure we're good. Now, I know with one-step equations, you guys can do that in your head. You probably don't need to write it down. But for the sake of what's coming next, I'm just going to go through the formal steps here. We solve it just like we would an equation. So I'm going to subtract 7 from both sides. I'm using inverse operations. So then I have x is less than negative 17. And then I'm going to graph it. Now, there's no equal to sign here. So x can't actually be negative 17. It has to be everything that's less than it. So I'm going to use a hollow circle to show that negative 17 is not a solution. And if I read this, it says x is less than negative 17. So I'm going to shade everything that's less than negative 17. And my graph looks like that. Now, it's a good idea to check to make sure you've shaded the correct side, both here and your original inequality. So if I plug in negative 19 here, is negative 19 less than negative 17?
Yes.
Yes, great. Okay, now if I plug in negative 19 here, negative 19 plus 7 is negative 12. Is negative 12 less than negative 10?
Yes.
Yes. So you're good. You're good. All right? So it's good to check like that and the other. Let's do one more.
What if I said x is equal to a negative number?
What do you mean?
Like what if I said x is equal to negative 18 and x plus 7?
Well, let's try it. So if x is equal to negative 18, negative 18 plus 7 is negative 11.
Negative 11, so negative 10 is greater than,
Yeah, so it still works. Yeah. And if I had plugged in like negative 15, like if I had shaded the incorrect side here, then this would be negative 8. Well, negative 8 is not less than negative 10. So you would know, oh, I must have done that wrong. Does that make sense?
oh, okay.
You good?
Yeah, because I was thinking something else. Oh, okay.
Good job asking questions and making sure that you understand. Okay, same thing here. I'm going to use inverse operations. The opposite of dividing by 5 is multiplying by 5. Colin, as soon as I say inverse operations, you look pained. Like it's the most horrible thing you've ever heard of. Okay, 5 times 24 is 120. And then graph it. Okay, we're saying that h is less than 120, so it can't actually be 120, so I'm going to use a hollow circle here. And because, you got to be careful when you're reading this because the variable's on the right side, sometimes people get mixed up. The arrow is pointing at the h, which means that the h is less than 120. So we're going to shade everything less than 120. And double check, is 120 greater than 118? Yeah. Now, it's a little tricky here because I'm dividing. So another solution here could be 115. So if I plug in 115 for h right here, and I divide by 5, I'm going to get 23. Is 24 greater than 23? Yes. Yes. Okay. If I had plugged in 118 there, I would have gotten a decimal and it would be messy. So I just picked something that I knew would be divisible by 5, but is also in my solution set. All right. You guys have the rest of class to get that homework done.
You don't have to write this down?
You do not need to write your homework down tonight. So enjoy it because it will not last. Absolutely.